Hello everyone, welcome back to another GIS mathematics lecture video. And in this lecture video, I want to go back through this example of the 2x2 matrix that we've already proven wasn't invertible using the 2x2 theorem that we developed. But now I want to prove it using the identity matrix method with augmentation, reduced row echelon form, because that's the method that you can apply to larger matrices, 3x3, 4x4, etc. And so what I want to do here is I want to redo the matrix. Let's quickly grab our white pen. So 1, -3, 1, 0, -2, 6, 0, 1. All right, that's the augmentation of the matrix we have with the identity matrix of the same size, right? And so if we go through the process of trying to put this into reduced row echelon form, right, we'll see that this is already a leading 1, so we don't have to worry about that, but we want to make this into a 0. Well, to do that, right, we would do 2 times row 1, right, to make this into a 2, and then add it to that to make that 0. Right, plus row 2 goes into R2. Right, that's the process that we're going to use. So if we do that, right, we're not changing the first row. The second row, right, 2 times 1 is 2, plus -2, this becomes 0, which is just like what we wanted. 2 times -3 is -6, plus 6, this is also 0, right? 2 times 1 is 2, plus 0, this becomes 2. And then 0 times 2 is 0, plus 1 is 1, right? Now you can probably already see the problem here, but let's go ahead and let's continue on with the process. So we move down to the right, this is a 0, so we keep going, right? This is going to be a 1, we want to make this into a 1. So to do that, now we do, we do 1/2 R2 going into R2. Right, I'm going to put the results down here. Right, we're not changing the first row, so it's still -1, -3, 1, 0. 0 times 1/2 is still 0. 0 times 1/2 is still 0. 2 times 1/2 is 1, which is what we wanted. And then 1 times 1/2 is 1/2. Okay, right. So then the next goal is going to be to make the number above this leading 1 a 0. So that's going to be to make this a 0. And that's simply going to be -R2 plus R1 goes into R1. So if we do that, right, we're not changing the bottom this time, so that's still going to be 0, 0, 1, 1/2. Right, -0 is still 0, so this is going to be 1. -0 is still 0, so that's going to be -3. Negative times 1 is -1, plus 1 is 0. This is what we wanted to happen. And then -1/2 plus 0, this is going to be -1/2. Right, so this now meets our qualifications for reduced row echelon form. But what I want to show you here is that this bit right here, right, this is not I, right? This is not the inverse matrix. Right, the inverse matrix we were hoping to get would have been 1, 0, 0, 1. Right? So because these two things aren't equal, right, this matrix is not invertible. Right? This is not I, therefore A is not invertible. Right, so again, this was a small 2x2 example, but you can extend this out to 3x3 and 4x4. Right, if at the end of the day, the matrix you get back is not the identity matrix, right, the left-hand side of this matrix is not the identity matrix, then you have a problem. and your matrix is not invertible. So hopefully that makes sense. If you have any questions, please reach out. Thank you.